So that misty patch of light is not a cloud in the sky. It's not even gas and dust in our galaxy. That is another galaxy. It's the Andromeda Galaxy.
In a startling revelation, UFOs appear to be communicating with us. With the James Webb telescope has just decoded a significant signal from across the universe. This is it. We're on the verge of alien contact. The message, from a galaxy billions of years old, unveils the chaotic birth of galaxies like Andromeda. Join us as we investigate whether this alien signal represents a friendly greeting or a terrifying warning for humanity. Chapter 1. Peeling back the century-old secrets of Andromeda. The Andromeda Galaxy has opened our eyes to the vastness of the universe, showing us that our world and our solar system are not the center of everything. This discovery made it clear that there are countless other galaxies beyond our own Milky Way, highlighting that our planet is just a tiny part of a much larger cosmos. For many years, we have been learning about the Andromeda Galaxy, but until recently, all of our knowledge came from observations made here on Earth. However, with the advent of advanced technology like the James Webb Space Telescope, our understanding is rapidly changing. The recent data obtained from this telescope has taken everyone by surprise, revealing that the Andromeda Galaxy is far different from what we had imagined. In this chapter, we will delve into the new findings about the Andromeda Galaxy and uncover the truths that have been hidden from us for over 100 years. A little more than 100 years ago, people thought of the Milky Way as just a dim, elongated cloud of light that could be seen in the night sky. This view was due to the lack of advanced technology.
Before moving on, don't forget to subscribe to our channel if you haven't already.
Many cultures and civilizations throughout history had their own interpretations of what the Milky Way was, often considering it the center of the universe or a meeting point between the heavens and the earth. It was Galileo Galilei, a pioneering Italian scientist, who changed our perspective of the Milky Way and consequently, the universe. In the 1600s, with the help of his telescope, a groundbreaking invention of his time, Galileo made remarkable discoveries. He found that the Milky Way was not just a simple streak of light, but a dense collection of countless stars, planets, and other space objects. This discovery shifted the entire paradigm of how we viewed our galaxy and its place in the cosmos. The Andromeda Galaxy, which lies closest to our Milky Way, serves as a bridge to understanding the vastness of the universe beyond our own galaxy. It is believed that the observable universe is filled with over 100 billion galaxies, each with its own vast number of stars and celestial bodies. Through the detailed observations made possible by Galileo and others who followed, we learned that the Milky Way is not the cosmic centerpiece we once thought it was. Instead, it is just one of countless galaxies scattered across an immense expanse of space, each contributing to the complex and magnificent structure of the universe. In 1750, an English astronomer named Thomas Wright came up with a fresh idea in his book, An Original Theory or New Hypothesis of the Universe. Wright guessed that the Milky Way was not just a messy bunch of stars thrown randomly in space. Instead, he thought it was a flat, even layer of stars, and he believed that this huge layer included our solar system too. Wright's idea was a big step in trying to figure out how the Milky Way was put together. But because the tools to look at the stars were not very advanced back then, people could only go so far in their understanding. They still thought the Milky Way was everything there was in the universe. Given the tools they had, it's understandable why they couldn't imagine much beyond that. However, the field of astronomy took giant strides forward in the 1800s, and by the time the 1900s rolled around, our understanding of the universe was evolving rapidly. In the 1920s, a major change happened thanks to Edwin Hubble, an American astronomer. He used a powerful telescope, the 100-inch Hooker telescope, at the Mount Wilson Observatory to study the night sky. Hubble looked far beyond the Milky Way and found distant nebulae. By studying these nebulae, he figured out something groundbreaking. They were not just part of our galaxy. Instead, they were completely separate collections of stars, entire galaxies on their own. Among these galaxies was one particularly close to us, known as the Andromeda Galaxy, or M31. This galaxy has been watched by people for a very long time, with one of the first recorded mentions being by the Persian astronomer Abd al-Rahman al-Sufi around the 10th century. He wrote about it as a small cloud on his star maps, which shows that even back then, people noticed this mysterious patch in the sky. The importance of al-Sufi's work is huge because he managed to spot Andromeda without any modern telescopes, just using his own eyes and careful watching. This is pretty impressive because Andromeda is one of the few galaxies that you can actually see from Earth without any fancy equipment. If you know where to look in the sky, you can spot it with your bare eyes. Of course, it won't look detailed like in pictures you might see from telescopies, but you'll definitely see that. There's something different up there, not just regular stars. This ability to see another galaxy with just the naked eye is truly remarkable, and shows just how special the Andromeda Galaxy is as an object in our night sky. It bridges our past observations with the present, showing us just how far we've come in our quest to understand the vast universe around us. Let's explore deeper into space and how people have been learning about it for years. Chapter 2: A Flash in Deep Space, Andromeda's Black Hole. It was not until 1612 that Simon Marius, through his use of the telescope, was able to provide a more detailed account of the Andromeda Galaxy. His observations and descriptions laid an important groundwork that would help future astronomers in their study of this vast and mysterious part of space. Then, in the year 1764, the famous French sky watcher Charles Messier added Andromeda to his famous list of celestial objects, giving it the designation M31. Unfortunately, Messier credited Simon Marius with its discovery, not knowing about the even earlier observations by al-Sufi. Despite this oversight, Messier's work was crucial in bringing attention to the Andromeda Galaxy. For the next century, astronomers from different parts of the world dedicated themselves to unraveling the secrets of Andromeda, building on the discoveries of those who came before them. The understanding of the Andromeda Galaxy took a huge step forward in 1864 when William Huggins, an astronomer from England, conducted a groundbreaking study. He examined the light spectrum coming from Andromeda and discovered that it was unlike the light from a normal gas cloud. This discovery opened new doors and allowed people to start understanding the true nature of Andromeda. It's hard to imagine, but the Andromeda Galaxy is so massive that it's estimated to have a mass between 1 and 2 trillion times that of our own sun. It's an enormous structure, floating in space, not too far from our own little corner of the universe. Over the years, as scientists have continued to study this galaxy, they have come to believe that the Andromeda Galaxy is around 10 billion years old. This makes it a very ancient structure, at least by human standards. The history of Andromeda is thought to be quite complex, involving a series of events and processes that have taken billions of years. Researchers think that Andromeda was formed from the combination of several smaller galaxies. These smaller galaxies, known as proto-galaxies, gradually merged together due to the irresistible pull of gravity. This process of galaxies coming together and merging is something that happens all over the universe. It's how galaxies grow and evolve over time. However, these cosmic events unfold at such a slow pace that they're impossible to observe in real time. We only notice the changes after they've occurred, by looking at galaxies like Andromeda and seeing the evidence of these massive cosmic mergers. For many years, space experts believed that the Andromeda Galaxy was much heavier than our own Milky Way. This mistake is understandable because we live inside the Milky Way. And when we look at Andromeda from Earth, it appears so big that you might think it's unbeatable in size. However, this is not true. Recent studies have changed these old ideas. The latest research has made scientists think again about how heavy Andromeda really is. At the same time, they've started to believe that the Milky Way might be heavier than they used to think. Everyone agrees on the size of the Andromeda Galaxy. It is definitely bigger than the Milky Way, with an enormous width of about 220,000 light-years across. In comparison, the Milky Way's width is estimated to be between 100,000 to 175,000 light-years. This makes Andromeda a giant in space, covering a huge area. This new way of thinking also shows how hard it is to correctly figure out how heavy galaxies are. Galaxies are giant collections of stars, gas, dust, and invisible stuff called dark matter. The total weight of a galaxy depends on how all these parts are spread out and move around. It's very hard to measure this accurately. It needs advanced tools and careful checking of data. Back in the 1700s or 1800s, people couldn't have done this. We need today's technology to understand these things, which is why we are only now finding out the truth. Understanding the true weight of galaxies is not easy. Scientists use special equipment and methods to observe and calculate. They look at how stars and planets move within the galaxies to get an idea of the overall mass. This process is complex and takes a lot of time and effort. As technology improves, so does our understanding of the universe. This is a reminder of how science is always evolving. What we believe today might change with new discoveries in the future. Moreover, this change in perspective about the Andromeda and Milky Way galaxies tells us a lot about the universe. It shows us that even things that seem certain can be questioned and re-evaluated. One of the most captivating parts of the Andromeda galaxy is what's called its active galactic nucleus, or AGN for short. This is a super energetic spot right in the middle of the galaxy. It's famous for sending out really strong light and energy across different types of light waves, from radio waves all the way up to X-rays. The reason AGNs are so powerful is that they have what's called a supermassive black hole at their center. These supermassive black holes are spots in space that are incredibly heavy but packed into a really tiny area. They pull in everything around them, including light, which is why they're so fascinating and mysterious. When space scientists look at this active part of Andromeda using really powerful telescopes, like the Hubble Space Telescope, they see something truly remarkable. But let's break down what we're talking about a bit more. First, let's talk about what a supermassive black hole is. Imagine something so heavy that not even light can escape from it, and it's all squeezed into a point in space so tiny that you can't even see it. That's what's sitting at the center of the AGN. It's like a cosmic vacuum cleaner, sucking in stars, gas, and dust from around it. This material doesn't go quietly, though. As it spirals in, it heats up and starts glowing really brightly, which is part of what makes the AGN shine across so many different types of light. Now, about those different types of light, or what scientists call wavelengths. Our eyes can only see a tiny part of all the types of light out there, but using special telescopes, astronomers can see the AGN in light that's invisible to us, like radio waves or X-rays. Each type of light gives them different information about what's happening in and around the black hole. The Hubble Space Telescope, along with other advanced space telescopes, lets astronomers see these phenomena in incredible detail. They can watch how the material moves around the black hole, how it changes over time, and how it interacts with the rest of the galaxy. It's like having a front row seat to the most energetic show in the universe. In the big space dance, we start to see the hidden moves of the biggest stars and galaxies. Chapter 3. The glowing heart of a galaxy. Inside the bustling heart of the Andromeda galaxy, something extraordinary is happening. The center of this distant galaxy, known as the active galactic nucleus, or AGN, is shining with an unusual pattern. It's as if the galaxy is winking at us with two glowing eyes, each a beacon of intense light and other forms of space energy. One of these glowing spots is particularly bright, sitting just a tad off-center from the galaxy's true middle. Hidden within this luminous area is a cosmic giant, a supermassive black hole, an object so massive that its weight is staggering to imagine, somewhere between 110 to 230 million times the mass of our own sun. These supermassive black holes aren't just the stuff of science fiction. They're a real and common feature at the hearts of galaxies, just like our Milky Way. They're the cosmic conductors orchestrating the galaxy's grand symphony, influencing its structure and how it evolves over billions of years. Now let's dive into what happens when space stuff, like gas clouds or wandering stars, gets too close to this immense gravitational force. They don't fall straight in. but instead start swirling around the black hole in a cosmic dance, forming what's known as an accretion disk. This disk is no ordinary whirlpool. It's a screaming, hot, spinning ring of material that shines across the electromagnetic spectrum, making the AGN one of the galaxy's most brilliant features. When astronomers point their telescopes at Andromeda's AGN, they're not just seeing a bright spot, they're witnessing the intense drama of gravity at play. Near the supermassive black hole, the dance of the stars is particularly fascinating. They move on stretched-out paths, like comets swooping around our sun, speeding up as they get closer to the black hole in a part of their orbit called the perihelion, the point of closest approach. At the perihelion, the tug of gravity reaches its peak, pulling the stars faster and drawing them closer together in space. Imagine a crowd of people suddenly running together towards a single point. They'll inevitably get squished closer, right? That's what's happening to the stars near the black hole. This cosmic huddle makes the stars shine more intensely, creating that brighter spot that stands out to astronomers observing the heart of Andromeda. This topic is about more than just an impressive display in the sky. The bright light we observe is full of important information. It helps scientists understand the strong forces of gravity that exist near enormous black holes and how these forces affect nearby stars. Learning about these interactions is crucial for understanding how galaxies form and evolve. Looking into the AGN, active galactic nucleus, offers a glimpse not just at light, but at the forces that shape the universe. The movement of matter around the black hole, the circling stars, and the emitted light are parts of a larger puzzle. Studying these phenomena allows scientists to trace the development and transformation of galaxies like Andromeda and the Milky Way over billions of years. The Andromeda galaxy is particularly interesting not just for its size, but for its large number of globular clusters. These are dense groups of stars that orbit the galaxy's center, similar to how planets orbit the Sun. Andromeda has around 460 of these clusters, each containing hundreds of thousands to millions of stars. This abundance of globular clusters offers insights into Andromeda's extensive history, including its interactions with and absorption of smaller galaxies, a process known as galactic cannibalism. When smaller galaxies are drawn into Andromeda's gravitational field, they are dismantled. Their stars and materials are assimilated into Andromeda, enhancing its complexity and diversity. This behavior is typical of spiral galaxies like Andromeda, which are characterized by their flat, disc-like shape and spiraling arms. They are adept at attracting and merging with other galaxies. Moreover, recent research suggests that Andromeda might be undergoing a significant transformation. It appears to be evolving from a spiral galaxy into a ring galaxy, a rare and intriguing type. Ring galaxies are notable for their circular formation of bright, young blue stars with a less luminous center. This transition from spiral to ring shape adds to Andromeda's uniqueness and provides a valuable case study for astronomers investigating the evolution of galaxies over time. Let's go into the strange parts of space where very unusual and rare space things happen. Chapter 4. Milkomeda, the future megagalaxy. In the vast universe, we can see three main types of optical ring shapes in galaxies: nuclear rings, inner rings, and outer rings. Nuclear rings are like the close-in neighborhoods near a galaxy's downtown, sitting close to the galaxy's center. Inner and outer rings are like the suburbs and outskirts, lying farther from the center. But the story of rings doesn't stop there. When we talk about entire galaxies shaped like rings, we split them into two groups: O-type and P-type. O-type ring galaxies are the more orderly ones, with their central hearts right in the middle and their surrounding rings nice and smooth. P-type ring galaxies, however, are the wild ones, with their hearts off to one side and their rings a bit messy and uneven. These ring-shaped galaxies are pretty special, kind of like rare jewels in the vastness of space, with only about one in every 10,000 galaxies making the cut. Astronomers have come up with two main ideas about how these unique galaxies come to be. One way is through a cosmic crash, where two or more galaxies bump into each other. Another way is if a smaller galaxy takes a dive through the middle of a bigger one, setting off a cosmic splash that forms a ring. Some famous examples of ring galaxies that might have been born from such dramatic events are the Cartwheel Galaxy, the galaxy duo known as 2026-424, and ARP-147. But let's zoom in from the cosmic scale to something a bit closer to home, something that's grabbing the attention of astronomers right now. Our very own Milky Way galaxy and our next-door neighbor, the Andromeda Galaxy, are heading towards each other like two cosmic freight trains on the same track. They're expected to come together and blend into a giant mega-galaxy, which people have already started calling Milkomeda or Milkdromeda, in a mix of fear, fascination, and a touch of humor. While these names might sound lighthearted, the reality of such a merger is anything but trivial for the future of our cosmic neighborhood. As the Milky Way and Andromeda draw closer, their massive gravitational forces will start to mess with each other's structures. This isn't just a friendly handshake. It's more like a full-on wrestling match where both sides are equally strong. This gravitational tug-of-war will create tidal forces, which are kind of like the cosmic version of the ocean tides on Earth. But instead of water, they pull on stars, gas, and dust. As these two galaxies start to intertwine and overlap, it's going to be a spectacular but chaotic dance of cosmic proportions. The skies as we know them will change dramatically, with new star formations, gas clouds swirling around, and a lot of celestial destruction. But don't worry too much. This galactic dance-off is set to happen far in the future, so we've got time to enjoy the show from a safe distance. As two galaxies start getting closer to each other, they begin to collide and come together. This big event causes the stars, gas, and dust from both galaxies to mix and mingle. This mixing can result in new groups of stars and structures forming in the combined galaxy. When these galaxies merge, the paths of the stars inside them change a lot, making the inside of the new galaxy very busy and chaotic. Some stars may even get thrown out into space, while others end up moving in new, stretched-out paths. Each of these galaxies has a really huge black hole at its center. When the galaxies crash into each other, these giant black holes will come together too. They will join to create an even bigger black hole right in the middle of the new galaxy. This coming together can start a lot of new star making, especially in places where gas clouds smash into each other and get squished, leading to the creation of areas where new stars begin their lives. These areas are like nurseries for new, big stars that will live in the new galaxy. As the two galaxies become one, the night sky turns into an amazing show of lights. This grand event will make the sky light up with new groups of stars, shockwaves, and powerful bursts of light. The night sky will go through a complete makeover, showing new patterns of stars and formations. Basically, the whole sky will look totally different and new. But here's the thing. While all these amazing changes are happening out in space, they have a deep impact right here on Earth. As the Andromeda Galaxy and the Milky Way come together, the huge forces and interactions between the stars, gas, and dust will cause big changes in Earth's environment. These changes might mess with where and how life exists on Earth, possibly changing the homes of animals and plants, shifting the variety of life, and even leading to the disappearance of some species. The joining of the two galaxies might also shake things up in our solar system, affecting Earth's weather and climate. We could see changes in temperatures, the amount and kind of rainfall, and other weather conditions across the globe. This could change where plants grow and where animals live. The amount of sunlight reaching Earth might change too, which could affect important life processes for both plants and animals. So the lives of many creatures, including humans, could be in danger, and these effects might start showing up sooner rather than later in the galaxy merging process. As the future comes, big star group stories mix with life's story, making us rethink everything about space. Chapter 5. How space weather could reshape life on Earth. Additionally, a rise in space radiation in the areas between galaxies could have serious effects on Earth's air shield, including the protective ozone layer. If this happens, the weather and climate all around us could start acting differently, which might make it tough for many kinds of living things to keep going. Changes in the air could mess with how plants make food using sunlight and air, a process called photosynthesis, which is really important because it helps keep all living things on Earth alive. As the weather and living environments change, the places where different creatures live could start to change too. They might become less welcoming or move to completely different areas. A lot of animals have certain paths they travel for finding mates, getting food, or escaping the cold. But if their homes start to change and the weather gets weird, these paths might get mixed up. This could make it really hard for these animals to find enough food, water, or safe places to have their babies. As the weather changes and places to live move around, the mix of animals and plants in different areas could start to change too. Some might find new ways to do really well, but others might find it super hard to keep up. There might be more fighting over food and space, and some animals or plants might find new chances to spread out and take over new areas. Sadly, not all animals can quickly get used to new living conditions. This means that some might not make it, leading to their disappearance from certain places or even going extinct just in that area. When animals and plants that used to live together start disappearing or moving away, it can upset the balance of the whole environment. This could mean that some kinds of animals or plants might stop being seen in places where they used to be common. These changes aren't just a problem for animals and plants, they can affect humans too. People depend on stable climates and healthy ecosystems for food, water, and even the air we breathe. Changes in the environment can lead to problems with crops, shortages of water, and diseases. Plus, when animals lose their homes or start moving into new areas, this can lead to more encounters with humans, sometimes causing problems or spreading diseases. While the thought of galaxies colliding might seem sad or frightening, the truth is this grand event is a slow process that won't happen for a very long time. This massive collision is predicted to start about 4 billion years from now, and it will take another 2 billion years for the two galaxies to fully come together. By that time, humans as we know them will probably not be around, and our Earth will have changed a lot even before the galaxies start to touch. In about 5 billion years, our sun is expected to grow into a huge red giant star. It will get so big that it will swallow up the planets close to it, including Earth. This will make our part of space a place where life as we know it can't exist, all happening before the two galaxies even start to merge. If there are any beings that come after us or other forms of life living around 4 to 6 billion years from now, they would be very different from people today. They would be so changed by evolution that they wouldn't look or act like us at all. As for what will happen to our solar system when the galaxies collide, it's a big mystery. There's a possibility that during the galactic crash, our solar system might get thrown out into the space between galaxies. But we can't say for sure what will happen to the new combined galaxy, which some call Milkomeda. The big smash-up might mess up the beautiful spiral shapes of both galaxies and scatter their stars all over. It's unclear if the new galaxy will end up round like a ball or stay flat like a disc. We really can't know for sure until it actually happens. But there are different ways it could turn out, and the new shape of the galaxy after the merger could be very different from what we see now. As the Andromeda Galaxy and the Milky Way start to come together, it's like a huge cosmic mix-up. Stars, clouds of gas, and dust will bump into each other and start to form a brand new galaxy. This new space home could have star systems with planets that are just the right distance from their stars, making them not too hot and not too cold. This is important because it's the kind of place where water can stay liquid, and we think liquid water is super important for any kind of life like what we have on Earth. But whether this new mixed-up galaxy is a good place for life to hang out depends on a lot of things. The way stars move around each other and the pull of gravity can shake up planets and change what it's like on their surfaces. If things get too wild, it might be tough for life to stick around or even get started. Merging galaxies is kind of like shaking a snow globe. Lots of activity and changes. This can mean more cosmic rays and big star explosions, like supernovas, or super bright flashes called gamma-ray bursts. These can be super powerful and could change the conditions on planets far away. But guessing exactly if and how this might affect planets and life is really tricky. If there's new life popping up in this brand new galaxy, it would have to get used to a whole different set of rules, like different weather, skies, and maybe even different chemicals to use for life. Life there might be totally different from anything we have here on Earth. But the people living today, like you and me, we're not built to live in this future galaxy. It makes you wonder, doesn't it? Can humans change over time to fit into this new place called Milkomeda? Is this new discovery from the Andromeda Galaxy a groundbreaking revelation, or is there a more explanation behind these signals? What do you think lies at the heart of this cosmic mystery? Share your theories in the comments, and remember to like and subscribe for more intergalactic updates.